So now we are going to be dealing with peak and off-peak markets. You are building a theater and plan to price your tickets for two markets, evenings and weekends are market 1, and weekday matinees are market 2. The ticket price in dollars for each market is listed below. So this is what happens in a theater back when it was safe to go to them. We would have peak and off-peak prices. Matinee pricing, not on the weekend. Matinee pricing on the weekdays was cheaper because what demand is lower. So to drive that demand up and fill the seats, they would price it at a lower value. What we have here are our two markets. We've got P1, demand equation for our market 1, and P2, our demand equation for our market 2. Q1 is the average number of tickets sold in a day to market 1, and Q2 is the average number of tickets sold to market 2 in a day. The variable cost in both markets is $2 per ticket. The capital cost is $10 per day for each theater seat. It costs to treat a customer as well as it costs to maintain the whole theater and have its general staffing levels. That comes down to about $10 per seat. You want to determine the optimal capacity for the theater to maximize profit. What is the profit equation for this problem? We're going to use a new letter, kappa, to denote capacity of the theater. So kappa denotes the capacity of the theater. And in general, for problems like this, we use kappa for capacity. Okay, so setting up a profit equation. Profit is going to be equal to revenue minus cost. That basic relationship remains the same. Now, what is my revenue? Total revenue is going to be equal to P1 Q1 plus P2 Q2. So this is going to give me P1 right here times Q1 is going to give me 160 Q1 minus 0.5 Q1 squared. P2 times Q2, so P2 over here is going to give me 120 Q2 minus 0.5 Q2 squared. Now let's get our cost function. So our total cost function is going to be, well, it costs $2 for every ticket to manage those customers. So it's going to be $2 times each ticket in market 1 that you sell, plus $2 times each ticket in market 2 that you sell. And then it's going to be $10 per day for each theater seat, or $10 averaging per day for each theater seat. So we're going to call this $10 times our kappa, $10 times our capacity. Okay, so now subtracting total cost from total revenue, I'm going to get profit is going to be 160 minus 2 for Q1, 158 Q1 minus 0.5 Q1 squared plus 120 minus 2 Q2 is going to give me 118 Q2 minus 0.5 Q2 squared, and then minus the 10 kappa. So there's our profit equation. That's what part A was asking for. What is our profit equation? We have succeeded at part A. Part B is now asking us, what are the constraints for this problem? So what are our constraints? What are our limitations? They didn't list any explicitly. We have natural constraints between supply and demand and getting our profit to not drop. But do we have a limit on how many tickets, for instance, that we can sell? Let's look at the number of tickets. How many tickets can you sell in a theater? The limit is how many seats are available, isn't it? It's the capacity. So when we're dealing with a capacity problem, the quantity that we can use is limited by that capacity. So in this problem, we would have constraint 1 is market 1's capacity the number of tickets it sells must be less than or equal to the capacity. In market 2, the number of tickets that are sold must be less than or equal to the capacity. So those are the constraints in a capacity type of problem. You can't overbook the theater. No overbooking going to be happening. And even when an overbooking scenario, you would have a limit to how much you overbook. So that would become your constraint. Okay, now we're going to write down the Lagrangian equation for this problem. Okay, so whenever we do our problem, what we do is we set up our Lagrange equation. So this is going to be a function of Q1, Q2, and kappa. That's what our profit is a function of Q1, Q2, and kappa, our capacity.
Our Lagrange equation is also going to be a function of our two constraints, so we're going to add lambda 1 and lambda 2 here.
So then this Lagrange equation becomes my profit equation. And then I have my two constraints. Lambda 1 is going to be times my capacity kappa minus Q1 plus lambda 2 times my budget is going to be the capacity minus Q2.